Welcome, everybody. It is 11 o'clock. We'll wait another 37 and a half seconds before we get started. If you have any questions, there's just click on the chat. Will pop up in my window here, and one of us will address those either uh, audibly or through the chat function. Right, we're down to about 10 seconds, and I'll just get started. All right, good. So my name is Brian Donahue. I'm the Vice President of Sales and Operations for Finsen Tech here in this hemisphere, so the North and South America. On the call with us today is Jess Hartman. He's my FNG, and he's in the same office with me, so you may even hear us echo when I put myself on mute. And over across the pond is our Chief Technology Officer, a gentleman named Tristan Williams. Tristan will chime in from time to time. He has a deep experience in the science of UVC. So again, housekeeping, just click on the chat if you have any questions. At the end, we can open it up. We have probably 10 or 15 frequently asked questions. We do these type of webinars quite a bit. Just some rules today. We are going to speak rapidly. I have a clock, kind of like pardon the interruption on ESPN. We're going to spend maximum 2 minutes on every subject and just keep going through this quickly. Otherwise, I could talk all day, and trust me, you don't want that. So the reason we pulled this together, there's so many UVC units that are out there, ultraviolet light, and there's a lot of noise that's going on in the marketplace. And I get questions from time to time on the safety, the efficacy, the deployment, the cost. And I just want to make sure that we can put everything out there, the do's and don'ts, with sort of a subject on the do's and what you should look at and what you shouldn't look at and be distracted by. Here's our agenda. We do have some a little bit of selling to do with Thor. We think we have the best mousetrap out there, and I'll show you why. And I have I'm going to try my best to not bash the competitors. The competitors actually got us to where we are today, and it's a beautiful system we have in the United States where we can bring in competition because they only make us better. If we don't have a better product at a better price with better service, then we're going to end up losing to them. So we want to make sure that we are better, and we have some very worthy adversaries in this market. But I'm going to try my best to blur the logos if I do put a picture of our competitor up there to show you some of the things that we see out in the market. Okay. So moving right along, why is all of this important? Well, we are governed by just a few physics principles. One of which is called the inverse radian square law, and the other one is the cosine law. Being a history major, it took me a while to sort of rationalize what this means. But now that I've been doing this for the last better part of 6 years, the the thing that the takeaway that you would have with the radian square law is this: you want to start with the most power, because as light travels over distance, the power, the efficacy, the power, the dose, the efficacy, the power diminishes exponentially. So when you go from 1 foot to 2 foot to 3 foot to 4 foot, if you measure the power of that light, it'll go 1/4 to 1/9 to 1/16 to 1/25. So starting with the most power is really important. The second thing is the cosine law. A lot of people just ignore it, but what you want to have is light come straight down on something. So by having a light that is as vertical as ours is, it goes from 2 inches and it telescopes up to 7.5 inches tall, or 7.5 feet tall. You'll see that light comes straight down, just like in the summertime when the sunlight is really hot at noontime, versus the wintertime when the sun is coming at a different angle. So those are the two constraints, physics constraints. The other thing is we would love to put 1,000-watt bulbs on our unit and have 50 of them. What we're limited by in the US is the power coming out of our wall sockets. In most cases, there are 110 volts, and you simply can't put too much wattage on your bolt or on your unit, or it'll trip the breaker. Okay, so it's not the wattage we look at, it's the amperage. So the lower the wattage, or sorry, lower the voltage, the higher the amperage. I hope that explains it. So we can't just build a nuclear bomb for an ultraviolet, disinfection, you know, because it won't work. It won't turn on because of the power that's coming out of the wall. So what we have to do is maximize what we have, and this unit that we have does exactly that. Okay, so we're going to get right into what's important, the do's and don'ts. Our natural enemy in ultraviolet light is creating shadow to get light that gets around that, under that, and over that. So here's a picture of a competitor actually in a lovely hotel room somewhere in California. And what jumped out of the screen wasn't that it was used in a hotel room. To me, it was that big shadow you see not only on the floor, but as you go up, the design of their unit actually blocks a lot of the light and the efficacy. So when it's being blocked, it's not disinfecting. Worse, and we'll get to this in the next couple of slides, is the design of this unit. Unfortunately, um, its strike zone is only about 4 feet to 5 feet in the air there, and the base underneath blocks the light underneath it. So when you move that unit, the wheels are actually dragging dirty whatever it is into the next room. Okay, so what you want to do is make sure that you have a design that minimizes the shadow. Okay. The Thor unit, you'll see, will telescope, and we have a base that allows light to get underneath it. So any shadow that Thor creates will be disinfected. Moving right along. So shadow management, understand the design limitations of a unit. So cross-contamination is closely tied to this. In the last slide, you saw the wheels were in a big shadowed area. In this case, this particular vendor has their motion detectors, their door blockers, the remote controls are what's pushed up against the wall. And if you notice, that's on the other side of that door would be their unit disinfecting a patient room. The problem is that these door blockers are on a filthy floor, and when they're done, the EVS staff will then have to pick that thing up and stick it back in their unit. So that will lead to cross contamination. Okay, so you want to make sure that you can address the floor, but also understand that anything that you're touching on the outside of the wall, whether it's one of those accelerometers that they put on the door handle so that it's like if the door moves, it turns off the system, any sort of even signage that you have on, you've got to make sure you address that cross contamination. But the filthiest part of a hospital is definitely the floor. So ignoring the floor, you're really risking quite a bit of cross contamination. This is dosing and accuracy is probably the most complicated thing. The idea and philosophy of having a robot is that you're supplementing, you're augmenting, you're improving what humans can do themselves. Sometimes you make it better, sometimes you make it faster. In this case, the robot is supposed to be doing the dosing for them. Otherwise, you're just pushing a unit into a an empty space, and it's guesswork. So what we've put up on this slide literally is copied directly from competitive websites. You know, like an average cycle time of 5 minutes, or hey, you can have cycle times as low as 2 minutes, or hey, we're doing 8 minute cycles for 1,000 square feet. Well, the problem is it doesn't tell you exactly what pathogen you're looking to kill, nor does it tell you how big of a space it is. So let me just tell you quick, like succinctly, everyone in this industry is the dose is determined by these four things. All of us have the same four determinants of dose, and dose in UVC is time. So it's the dimensions of the room, how big a room is. It's the contents of the room, stuff that's in it, creating shadow. You have to get under and over. It's the position of the unit within the room. If it's in the middle of the room, it actually halves the time. If it's on the far end, it takes longer and more power. And the last thing is what pathogen you're looking to kill. Dr. Kowalski has a really nice index out there that shows the power of UVC on any um, pathogen out there. And what we do at Finsen is we try to kill the most difficult things. So COVID and TB are a little bit easier to kill. MRSA is a little harder to kill, and C. diff is probably the hardest to kill. So we measure our success on the hardest thing. And the idea is that if we can kill the hardest thing, it's going to continue to kill the easiest thing. So those four determinations again: dimensions of the room, contents of the room, position of the unit within the room, and what pathogen are you looking to kill. So when someone says, hey, we can do a 2-minute cycle, so can I. Put that thing in a bucket, it'll take less than 10 seconds. You put it in a small bathroom, it'll take less than 2 minutes. You put it in a school auditorium, there's no way you could disinfect that. In fact, one of our competitors put it into an arena, like a basketball arena, with the caption that said, trusted by this basketball team. And, my head sort of exploded. There's no way that unit could ever disinfect a basketball arena in 2 minutes. Okay. One other thing, true power. One other thing I want to mention. I want everyone on this call to understand how circumspect this industry is, and it's unfortunate. We are very transparent about our technology, about our features, and we have bulbs. We have a partnership with Philips, and we use our 95-watt bulbs, and we use the ballasts, and we share that because we think that Philips does the best job. And we want to make sure that the power going into the bulbs is at the right level to maximize that UVC. If you don't, you end up producing light low down in the 200 to 100 to 200 nanometer spectrum, which produces ozone, and that's a problem. Or you have other issues, and you can produce IR. When you look at this picture here, this actually is a competitor. They didn't blur out their it's a Philips bulb. You can see through it. But what's nice about it is it allows us to multiply how many bulbs they have by the wattage they have, and then we can look up the MSDS and some of the other manufacturers' cycle to see exactly how much UVC that unit produces. So then we can have an apples to apple comparison. So we have 24 95-watt bulbs from Philips that put out about 28 point something, 28.1 watts of UVC. So you multiply 24 by 28 and you get 674 watts of UVC. All right, so the 2280 is electrical watts, not UVC watts. The problem is with this nice competitor, we can calculate how many bulbs they have and what their wattage is, and we can look up what their UVC is. But most of our competitors don't share that. They'll say that they have a proprietary bulb and they don't tell you the wattage whatsoever. Okay, it's super important to understand how much power by how many bulbs. There's a couple of systems out there. I can go through each one of them. Should you want to address that later on, drop me a note in the questions. Okay, true power. Don't equate electrical power for UVC power. It's not that. And the second thing is always, always, always question what the wattage is of those bulbs. Right? Okay. Smart design is a very it's a cornerstone of our philosophy. It's design, power, and accuracy. We don't want anything blocking the light. Okay, so in this situation, you'll see that our handle, the halo that goes around our units, the only thing that would block the light. We've taken all the bars out, anything that would block light. Some of our competitors it's literally a box on wheels where the unit will come up and it has a 6-inch bulb that shines light at about 4.5 feet in the air. It eliminates any light hitting the floor, and it causes other cross contaminations problems we talked about. So if you notice this right here, this is our base, the Thor's base, right? You can see that we call it a spider design, but it's really 6 wheels, and light will get in between each one of those wheels. It also has holes within the casters so that light can get into the actual wheel itself. And more importantly, underneath the Thor, we have an array of LED lights that will disinfect directly underneath it. Right where if you can see my cursor here, I have to hit annotate, put my cursor up. Right here where you see my cursor, you'll see there's shadow under there. That's where our LED actually disinfects the floor. It's about 2 inches off that floor, and we go from 2.5 inches up to 7.5 feet tall with very, very little light blockage. Okay, so the design is super powerful. Some competitors actually look like a lighthouse. They have light that's about 60 degrees and it rotates like this, which is fine. So 60 degrees of light shining this way means that you have 300 degrees of darkness behind it. And you're going to have to spin around quite a bit to be able to do a 360-degree cycles like what Thor does. Okay, so back to design, power, accuracy. We're getting to all these things here. We talked a little bit about ballasts and matching up bulbs. Understand that light has a wide wavelength range, and different lights, so invisible light, or sorry, ultraviolet light is invisible, and it goes from about depends on who you Google, from 100 nanometers. Typically, we say about 200 nanometers up to 280. Okay, then UVB continues 280 to 315, and UVA goes from 315 to 400. At 400, light becomes visible. And as it continues along that range up to about 700, and then it becomes infrared, where it produces heat. What's super important is that you do not produce ozone, especially in a healthcare environment. There's literally a CFR that 801.415.C2. You can look it up. Don't take my word for it. Google it. They don't want, this is the code, federal enforcement. They don't want ozone produced in a hospital. It's explicit, or anywhere there's the infirm. Okay, so producing ozone is against the regulations. Ozone is a respiratory irritant. Just so happens I have a couple ozone lights, cheap Chinese lights that I bought just to test out, and I nuked it downstairs. And this morning when we walked in, the whole building smelled like ozone. The cool thing is when I turned my Thor on, it eliminated all that ozone smell. Okay, so we know that our light at 253.7 can break down ozone, but just avoid ozone altogether. And that's what you're going to see with a lot of those pulse xenon lights, the flashing lights, because they have such a wide range of light. Excuse me. Getting back to pulse xenon. So our light is considered a continuous wave, which means when it's on, it stays on. So we're getting great dwell time. Pulse xenon light actually turns on and flashes and then turns off. It's actually on for less than 1%. So let's just say it's 99% that there's no light at all. It's not actually doing anything, right? And the light that is on is so intense, don't take my word for it. Look at their website. Competitors will say it's 10,000 or 100,000 times the intensity of the sun. What they mean by intensity is visible light. Visible light's non-germicidal. So when it's 100,000 times the intensity of the sun, it means it's super bright to the extent that you have to put curtains up because it blinds people and it causes seizure disorders and it's distracting and it actually makes noise with the capacitor. So what I recommend you do is that you take a hard look at whether you want to have pulse xenon, because there's a whole lot of reasons you would use it, and there's probably 10 times as many reasons you wouldn't. Having a nice, consistent light that allows for dwell time is preferable over that pulsed xenon. Brings up something else, motive units. So a lot of banter is going out there about robots and autonomous units. Autonomous doesn't mean that there's no human. These units do not open doors. And if you're in a healthcare environment, you're going to have to map the room, make sure none of the furniture moves. And even if they have LiDAR and all the other RGB cameras, they don't open doors. So it's very important to understand that you're not saving a whole lot in labor, but more importantly, because they're motive, they use battery. And to have the battery power enough light to get proximate to all the different areas that needs to get disinfected, we're talking about a lot of weight. And if you have a lot of weight, God forbid those things ever die on you, because you're going to have to push a 400 or 300 pound or a 200 pound unit without any handles on the thing. More importantly, by maximizing, we talked about this our first slide, by maximizing the power outlet coming out of the the wall, we know exactly how much maximum power we can have in a room. Okay, so these battery operated things work for about 2 hours. This is based on some owner's manuals I have. They take 8 hours to charge. They don't go up gradients, so it doesn't, go up a hill or anything like that. They don't work really well on carpeting. And in this picture right here, you can imagine this thing driving around and the cross contamination that goes on because of the design limitations with the base. It's only doing the strike zone from about 3 feet to 5.5 feet in the air. Okay, so motive units, they drive really close to things and they can, but there's no dwell time. It's like cooking a steak with a match and waving that match over the top of it. Okay, dwell time is more important than temporary proximity. And lastly, I would say that total cost of ownership should be pretty easy to predict. I would challenge every customer to ask for this. What's the predicted total cost of ownership? If the unit is supposed to last 5 years or 7 years or 10 years, what's the acquisition cost? What's the maintenance cost? What's the service plan? What's the repair? And that'll give you kind of an idea of what you're paying for from start to finish. Thor does not have consumables. Most of these don't have consumables. There are some units out there that will be less cost up front as an acquisition, but then you have to buy these dosimeters, these plastic cards, and they cost a lot of money over time. We use digital dosimeters in ours, and what we also do is we want to make sure that once we deploy a Thor, that the hospital customer is self-sufficient. They know how to fix it, so there's less downtime. We also have a beautiful bumper-to-bumper warranty, parts, labor, travel. And so they have assurance that this thing is not going to go down. If it does go down, it's not going to be a massive repair. And we have techs on the wings ready to fly in should there be a need for a tech. Our unit is open architecture. It's very easy to fix. The bulbs are toolless design should you ever break a bulb, but you should never have to change a bulb. Our bulbs will last 9,000 hours. That's the going rate for our Philips design bulbs, and that's more than a year's time, which falls into the PM schedule of our service. Okay. Okay. Labor is another one. What does it take to run a unit? Well, there's transportation, there's setup, and there's breakdown. Okay. So in this particular unit, this is a triple emitter. I just got done in a hospital where they converted from this system to the Thor, and everyone kept saying yours is so much lighter, so much easier to transport. They didn't have to wait for elevators because patients are in beds and elevators because this thing takes up a lot of space. The guy that had to push it around, he had to turn sideways, and he says it kills his back. But more importantly, when he was setting the thing up, it took a good 10 minutes to set the thing up. You have to put a unit in the bathroom and two on other sides, and then have them sort of communicate to each other. They use Bluetooth, and they had all sorts of communication issues. And more importantly, I asked them, how long does it take to do a room? And they said for this particular room, that was a patient room with 2 beds and a bathroom, an hour. And again, my head exploded. I couldn't believe it would take that long. So what does that person do in the meantime? Does he leave the system, then go down and do another room? They've got to stay pretty close, and you don't want to take up all that time. What's cool about the Thor is it does have PIR sensors, so it's totally safe to leave it in a room. Anyone who walks into that room, it's going to turn off immediately. It doesn't have an issue with like people walking by a window, like when you're in an ICU. They walk by a window, it just, because it's motion detector, it turns off. Ours are Panasonic PIR sensors. So it measures human shapes, 4-degree temperature change, and motion. So totally safe, and it allows you to just plug it in, place the unit, turn it on, and it runs itself. It tells the user exactly how much dose, how much time it's going to take. Okay, so we're saving time. So What we do is we look at the design, power, accuracy. What we're trying to do is to build quality and efficacy into every single cycle. We have validated energy that disinfects an entire room, and at the end of that cycle, we share that information with the customer vis-a-vis their reporting system. We have constant training. We go through the reports with the customers to make sure that they're optimizing the placement, they're optimizing the dosage. And when you look at the total cost of ownership from acquisition to training to all the other aspects of ownership, Thor wins. I did talk a little bit about digital dosimeters. We have these cards. We used to sell them. But the problem with those cards is that they change colors. They go from yellow to orange to pink, and there's companies out on the internet that are selling, I'm sure, a boatload of these things. We just didn't like them because they're not reliable. And 10% of all men are colorblind anyway. So trying to differentiate between orange and pink, it was difficult. So what we've done is we partnered with a couple companies, and I can give you the names of these companies that have a digital dosimeter. So as you put the UVC unit in a room, you can put a digital dosimeter in the far corner of the room and measure the actual UVC output. And that'll validate that you're getting the optimal UVC dosage. It's super, super important. Another thing that we wanted to bring up that it gets confused and lost in the noise is the British standards. We're one of the first, if not the only company that has complied and met all the standards for the British Standards Institute. So that BSI 8628 is a big deal. Google it, find out what it means. It's essentially the British Standards Institute set up a performance criteria for using UVC in a hospital environment. It's not a register your unit to be used. It is a performance standard. And furthermore, and Tristan can talk about this, furthermore, the European Union is going to probably adopt that. And we need to take that sort of stance here in the US on performance standards, not just it pays you money and you register your company. Okay. One final note here, I want everybody to remember with UVC, the 4 determinations, right? It's the size of the room, dimensions of the room, contents of the room, position of the unit in the room, and what pathogen you're looking to kill. What that will do is allow you to determine what the dosage is, and dosage is time. Okay. So key takeaways, I'll wrap this up. This is so obvious to me, but not all systems are created equal. And obviously everyone has patents, so you can't copy them anyway. But the point is, don't be distracted by a couple of things. There's sizzle and there's steak. Don't be distracted by the sizzle and these whiz-bang shiny objects over here. Look at the science, the design, the power, your accuracy, and don't be fooled by snob appeal. One of the biggest problems we've had to overcome in this industry is the top market share leaders are so expensive. And that paints the entire market with ineffective, very expensive units. And unfortunately, we've all had to overcome that. Okay, so we would love to drag race with anyone that's out there. Just last week, we did it with 2 of the top competitors and destroyed them, and we got the orders. Okay, so look beyond the hype, design, power, accuracy, and understand that globally, what we're trying to do is perform clinically and economically every single time. Okay, so what are the next steps? If you want to learn more, you can email us at hello@Finsen Tech. You can ask for a live demo, but first step should be go on to our website, kick the tires a little bit. We don't have just one thing. We've got a number of really cool modalities that we sell, and Thor is just one of them. Okay. With that, I can take some more questions. I can tell you that one of the questions we always get is how long does it take to disinfect a room, right? That's always our first question. And the answer always is, it depends on dimensions of the room, contents of the room, position of the unit in the room, and what you're looking to kill. So just last week, I was up in a facility in New York, and I asked them how long does it take with their current system. They said, with a small bathroom, by the time we get it all set up, 15 minutes to get it set up. It takes about 5 minutes to disinfect this bathroom. And when I showed them how it was 2 minutes and 15 seconds start to finish to put our Thor in their bathroom and nuke it with all the dosimeter readings showing that we're not only effective, but we're killing some of the worst pathogens out there. And that's also directly underneath where the toilet was, where it's really disgusting. When you mop a floor in a bathroom, all you're doing is making it uniformly dirty. So when you take that philosophy of a small space with shiny, and reflective tiles like a bathroom, and then you look at a larger space like an operating room. Operating rooms will take longer because they have booms and lights and anesthesia machines and OR tables and Da Vinci's. It could take up to an hour to terminally disinfect an OR, a complicated OR. Typically, if you're looking at just the high touch areas, it's less than 10 minutes. Okay. We even have surgeons that want to do it in between their orthopedic cases, and we just tell them 3 to 5 minutes. It depends on how fast they can flip a room, whether it's 3 minutes or 5 minutes. So, any other questions here? All right. Another question I get all the time is how big of a room can you do? Comes right down to depends how much time you have. Okay, so what we're governed by is that inverse radius square law. But also, we're talking about pi r squared. So that's the area of a circle. So if the radius is larger, right, pi r squared, right? So if it's 30 feet in radius, that's 900 feet times pi. So that's like it's a huge room. It's a huge room. It's just going to take longer, and it's not because of the limitations of our unit. It's the limitations of light, physics, and the power coming out of that outlet. Okay. So we can go up to 100 feet in radius, but just going to take a lot longer. Okay. Got another question here. What is the how many hours does it take? Okay, so we have 9,000 hours is what our bulbs are rated at. That doesn't mean that after 9,000 hours you need to swap them, because maybe you're not utilizing it for those 9,000 hours. So they could go longer. So it's like, and again, Tristan can correct me, up to 2,500 cycles. Okay. All right, let me go back to here. What type of device? Okay, so the actual remote control, this is important. We use Wi-Fi. Thor has its own Wi-Fi. We don't borrow from the hospital. They get really freaked out by cybersecurity and Russian hackers. So we have our own connection through Wi-Fi. We do not use Bluetooth. You go around the corner in a hospital, it's like a Faraday cage. It's all concrete and steel, and you lose signal. And there's nothing more frustrating than to come back to your unit and seeing that someone walked in and the unit's turned off and you didn't know about it. Okay, that's what I was hearing from this competitive account this last weekend. Is every time someone walked by the window, it would turn off. So they had to draw the blinds. Okay. So having a Wi-Fi allows us to communicate very reliably. And this hospital asked us, what's the range? And I said, I don't know, go down the hallway. And they did. So I had a laser, I have a laser ruler that allowed me to measure exactly. I think it was 148 feet when they finally turned the corner and went to a nurse's station, and we still were operating our Thor from that. That's what Wi-Fi does for you. We also use what's called a Microsoft Surface Go. It's a beautiful tablet. It has great battery life, great durability. It's got bumpers and all these other features that allows us to get maximum utility out of that Wi-Fi. It's not some junky Android tablet. Okay. Okay, good. For a 1,500 square foot in open space, approximately how long it would take to disinfect? That's a tough question, because a couple of things you're missing in that question. You're giving us the dimensions of the room this way. So if I divide that by 3.14, right, you end up getting 500 square feet. So then I can square root that and get you an idea of what the radius of this room is, but it's not telling you. So we got the dimensions of the room. We don't have the contents of the room, and we don't have what are you looking to kill. Okay. So we also don't know if we're assuming that we're going to put the Thor in the middle of the room. That room would take about 15 minutes. Okay. 15 minutes. If it's a cube with white painted reflective walls, it would take less. If it was, cluttered with all sorts of stuff like you see in my office here with, desks and chairs, it'll take longer. All right. Any other questions? Tristan, I hear you wheezing on the other side. Is there something else that you want to talk about? before we wrap this up?
I don't think it's wheezing, Brian. I think it's just the fact I probably got my microphone too close to my mouth, but thank you. No, I think you've covered everything exceptionally well. I mean, the only closing statement I would make is if you want to know more, please ask. Both Brian and I have a lot of experience in this industry. We are very ethical about the way our products are represented, sold, serviced, maintained, and used. And if there's any further details you want to know, you have our contact details. Please do just reach out. We're more than happy to engage, more than happy to discuss. And also, we're very happy to put our money where our mouth is. And exactly as Ryan said, drag race against any other product. We're very confident in Thor product, its ability to perform, its proven clinical efficacy, and the way it behaves in the marketplace. So anything you need, please don't hesitate to ask.
Yeah, so I wanted to limit this to a 30 minutes. I've gone over a little bit. I'm going to turn off the chat here in about 10 seconds. If you have any questions, get them in now. All right. If not, I want to see all of you on our website, and please check out Thor Kills More or Finsen Tech. I've got it right here. We also have a new product called Hermes that's really cool. Hermes UVC. Well, thanks, gang. I'm going to give you the rest of the day back to you, and hope to see you here in a month. We have another exciting new webinar coming up.
Thank you, everybody, for attending. We appreciate it.